Hello friends and welcome to the basic course of engineering circuit analysis. So we are continuing the discussion on the dependent sources now. So I told you we will be doing a small demonstration using a software called SQL GUI. So before starting, let me tell you something about the SQL GUI software. Now this is a really wonderful software which is developed by IIT Bombay. I think you all should download this software, and there are a lot of interesting things that you can do using this particular software. So you can just Google SQL GUI IIT Bombay and you will be getting the download file. So I will also be using this to just simulate this particular circuit here. Now this circuit has a lot of elements. As in matter of fact, you don't have to bother about the working of the circuit. You just have to see the points which I am trying to mention here. So this has a voltage source here. This is an independent voltage source V1. Okay, let us call it that this is as 12 volts. Okay, this is the 12 volts voltage source, and there is something a little bit special about this voltage source. I will tell you later. And you are having two resistance R1 so and R2. Okay, and here you are having your voltage controlled voltage source. This is your voltage controlled voltage source. This is your voltage controlled voltage source. And here you are having another independent source V2. Let me call it as, say it is 5 volts measuring, and here you are having another resistance R3. Okay, and now let me mark a few points here. So this point, let me call it as A, and this point, let me call it as B. So basically what is this voltmeter doing here? This voltmeter is measuring the voltage of A with respect to B. So idea is that the voltmeter, this voltmeter here, it is measuring the voltage VAB. Okay, and let me call this point X here, and let me call this point here as Y. So this voltmeter will be measuring the voltage VXY, that is the voltage of X with respect to Y. Now I told you there is something special about this voltage V1. So the idea is here is that I just want you to understand certain things here. Now this voltage control voltage source which I have defined here, voltage control voltage source, which has a magnitude of Vxy. You can see that it is basically this X and Y are across this particular element here. So this Vxy, or the magnitude of the voltage control voltage source Vxy, I will be defining it as 10 into VAB. Okay, so whatever is the voltage across VAB, the magnitude of Vxy will be 10 times the magnitude of VAB. This is the meaning of voltage control voltage source. So here you can see Vxy is basically a function of VAB. So as VAB would change, Vxy also would change. Now to show you the fact that a change in VAB will affect the magnitude of Vxy, I have made this voltage source in a special way. So the idea here is that when I put V1 as 12 volts, you might think that it is a 12 volt source like this. But no, I have made a small change here. What I have done is that the voltage V1 will gradually build up to 12 volts. Okay, so it will start with 0, and in 100 milliseconds, it will become 12 volts. So the graph of V1 will look something like this. Okay, so it will gradually build. After 100 milliseconds, it will become 12 volts. Okay, so that is the thing which I have done here. So let us see what is the graph that you might expect by using something like this. Okay, so let's plot the graphs. Now understanding graphs in any electrical engineering is very important. You should all understand how to plot graphs. So let me first plot the graph of V1. Okay, so I've told you V1 will look something like this, right? So V1 will look something like this. And at 100 millisecond, okay, at 100 millisecond, it will become 12 volts. It will gradually increase something like this. Okay. Now, the next graph I want to plot is VAB, which is the voltage across the points A and B. Okay, basically is the voltage across this particular resistor. Now, I will not give you the magnitude across VAB, because for the understanding how to calculate the magnitude, you should understand Ohm's law, which we have not taken up till now. But we don't require Ohm's law to understand the concept. We just understand as V1 changes, okay, as V1 increases, VAB will also increase gradually. Okay, so VAB also will increase gradually. Okay, and after 100 millisecond, V1 becomes constant. So VAB also will become constant at some particular value. Okay, at some particular value. The third graph that I want to plot is Vxy. Okay, this is Vxy. Now remember, this is all the x-axis for everything is based on time. Now Vxy, you know that it is 10 times VAB. Okay, Vxy is 10 times VAB. Okay, so as V1 increases, VAB will increase, and so will Vxy. And how Vxy will increase? Vxy will increase by this relation 10 times VAB. Okay, so here the graph will look like this, increasing, increasing, increasing. After a point, V1 becomes constant, VAB becomes constant, and Vxy also becomes constant. Okay, and Vxy is equal to 10 times VAB. So this is the graph basically that we are going to plot. We will plot these two graphs here for the simulation. So now let's go to the software. So here we are having the software interface. So you can see the voltage V1 here. So if you look at the property of this particular software, you see that I have put it as a ramp signal. Okay, so the final voltage will be 12 volt, but that 12 volt, it will gradually increase and it will become constant after 100 milliseconds. So I have defined that particular change which I have to make in the voltage in this particular property here. Okay, and here you are having A and B nodes. This is your resistance R1, resistance R2, and this is your resistance R3. This is the second voltage source V2, and here is the important part. This is your VCVS. Okay, so VCVS, you can see that I have put the control nodes. I have told you this is a controlled source. Okay, so it is controlled by the nodes A and B. Okay, so it is controlled by the nodes A and B. So basically this means that this VCVS is a function of the voltage VAB. Okay, so that's the basic idea. The concepts of nodes, branches, etc., it will come in the following videos, in which we will be looking at all these concepts in very much depth. But for the time being, you just have to understand the points which I am trying to mention here. Okay, and I told you Vxy is 10 times VAB. Okay, so that 10 times I have put it as a parameter alpha here. Now this is the property of the software, so I can put it as 10 times, 100 times, or any value that I like here. Okay, so basically now you have seen what you will get here. You will see V1 is going to change from 0 to 12. Okay, in 100 milliseconds. After that, it will become constant. So VAB also will change accordingly, and Vxy also will change accordingly. But Vxy and VAB are tied by the relation that Vxy is equal to 10 times VAB. Okay, so let's run the software here. So I need x-axis as time. So I'll select x-axis as time, and I need the graphs Vxy and VAB, right? Vxy and VAB. So I'll plot the graph here. Okay, so you can see the graph has come up. So let me just make the points a little bit bigger. Now this rows graph that you are seeing here, that is your VAB. Okay, so as V1 changes, you can see that the VAB is also changing, and after 100 milliseconds, this value becomes constant to some value. Now I told you the value is not important. Just look at the change. Okay, and the most important change that you have to see is Vxy. See, Vxy is this blue graph here. The Vxy is this blue graph. The Vxy is 10 times VAB. Okay, and so as VAB is increasing, Vxy is also increasing, and at every point here, at every point, if you see, for example, you see at this point, this is 4 point, this is, let me just take it at this point here, that will be better. Okay, so at this point you can see, look at the value, it is 6 volts, 5.9 volts, 5.9 into, sorry, 1 second. So in this point, at this point, it is 5.9 into e power 0. You can see in the right side. Don't take the first value, take the second value here. This 5.955 into e power 0. Okay, e power 0, it is 10 power 0. At the same point, if I take Vxy, you can see it is roughly, I have not taken the exact point here. Difficult to take the exact, yeah. So 5.988 into 10 power 1. Okay, 10 power 1. So this was 10 power 0 and this is 10 power 1. So clearly, Vxy is 10 times VAB. Okay, so this was like 6 volts. So this is 60 volts here. So that is the relation. At every point, this relationship is active. So I hope you have understood the concept of voltage controlled voltage source. The voltage of Vxy, the voltage of this particular control source, is dependent on the voltage of this particular VAB quantity. And as VAB changes, you can see again that as VAB changes, you can see Vxy is also changing, but it will be always 10 times the value of VAB. After VAB becomes constant, you can see Vxy also has become constant, and at this value, if you see, it is 6.29 at this particular point, and here it will be 10 times that value. Okay, so I hope you have understood the concept of VCVS in generally dependent sources. In the next video, we will be starting some numericals. Thank you.